Today we're starting a new chapter, so make sure you have your name on this. Alright? I didn't put it on your desk.
It's Axel's.
Yeah. Oh, underneath there. I'll grab that from you. Alright, so make sure
Put your name.
your name or block is block D. Alright? Now, this chapter that we're going to start today is about the same size as our previous chapter. So we're at the middle of October right now-ish. It took us about a month and a half to do the first chapter. This one will take us about another month and a half-ish as well. All right, so we should be wrapping this chapter up around early December sometime. Right? Yeah. Right, so you guys did really, really well overall on the chapter class we just finished. And I hope that you guys keep up the effort and you guys do really, really well on this chapter. Right? Now this is the last time you're going to have a dedicated chapter on this concept. Alright, I'll talk about what it is in a moment. So, rationals is a type of number. So you're used to numbers, but numbers have names to them. Right? In elementary school, you start off with working with whole numbers. 1, 2, 3, 4, those 5, those keep on going. Yeah. Those are called whole numbers, and you learn how to do all the math operations, add, subtract, multiplying, and dividing. Right? Then, basically, other than the addition of decimals in there, that's your elementary school career. Then when you got into grade 7, grade 8, we expanded from these set of numbers, and you got negative numbers as well. Negative 4, negative 5, negative 3, negative 2, 1, 0, and those numbers. And those were called integers. Right? Right? So, this is a number. This is another type of number.
Mr. Dhaliwal, do we read this?
No, you don't have to. This is my warm-up here. Right? Then, for most teachers in grade 8, the second chapter in the year was dealing with our current chapter. But we didn't use this name last year. Right? When you had numbers that looked like this, we called them fractions. Right? Those are called rationals. Right? Just a different type of number. Right? And once again, just like with all the other numbers, what did you do? You learn how to add, subtract, multiply, divide, do bed math. And that's basically what we're going to do in grade 9 with one extra step of comparing stuff. So grade 9 is the last year that you get a dedicated chapter on working with fractions. Fractions don't disappear, right? Like last year was the last year that was on shapes, right? This year is the last year of fractions, but now fractions just show up part of all the other chapters you can learn about. And you're expected to know how to do all the different kinds of calculations, how to add, how to subtract, how to multiply. So this is our last year of kind of reviewing and getting a good solid foundation on it. Right, so grade 9, this chapter, it's similar, very similar to grade 8. Maybe a little bit trickier for some of you guys because it has more negative signs and all that kind of stuff. Right? Other than that, it should be hopefully not too bad. All right. So today's chapter is just getting used to the vocabulary, right? So it's about reviewing and terminology. And the first word that I want to talk about today, because the main idea for today is the word equivalent. All right? Does anybody know what the word equivalent means? What it sort of, right?
Isn't it like equal the same percentage?
You guys are using the right words, right? It has the word equal sort of in it, right? The same value. That's what it means. Same value, right? Or equal to. And we're used to the symbol this. Well, equal symbol. All right? All right? So, we started off with this beginning of this lesson, I showed you what whole numbers were, what integers were, or what were fractions, right? Those are just certain types of numbers. Sometimes one format of a number, for example, this mixed fraction right here, may be harder to do whatever they're asking you to do. And we want to change it to another format, right? And maybe it's easier to compare. Maybe it's easier to do a calculation with. The key thing is we change how it looks, but we don't change its value. We just do it to make our calculation, our life easier. So now, one of the things that we had to do last year is if we have a mixed fraction. So remember, a mixed fraction is when you have a number, a whole number sitting outside like this, and we had to change it to improper fraction. Does anybody remember how that happened? So remember, improper fraction, or just a regular fraction, is you have two numbers. You have a number on the top, and you have a number on the bottom. How do we convert this? Yes, Nika?
So the whole number times by the bottom number
Yep.
plus the top.
Plus the top, right? So if you multiply these together, so 3 times 1 is 3, add the top, 3 plus 1 gives us 5. What number does that give us? Does that give the green number or the purple number?
Green number.
Green number, that is our numerator, the top number, right? So that gives us here 5. So we're still missing a part of this fraction. We're missing the denominator, the purple number. What number is that? 3. 3. That never changes. That's what we started off. All right? Okay, so now these two things say the exact same thing, right? So the bottom number tells us how big our slices are cut up to. So if you had a circle, right? So the bottom number tells us, hey, this is cut up into thirds. That's how big our slices are. The top number tells us, hey, how many of those pieces do we have? So we have 5 of them. 1, 2, 3. That means we must have another full circle with another 2 more in there. Right? So 5 thirds. Right? And these two things say exactly the same thing. Right? This one says, hey, we have 1 full one and 2 in the other one. Right? So they say exactly the same thing. Depending on what we're trying to do, it might be easier to look at one number versus the other number. But they have the exact same value. Right? I'll tell you right off the bat. Your final answers, you probably want it in this format. I won't care so much in grade 9. But this format, the improper fractions, is usually easier to do all your calculations with. So if you're given like this, you typically and then convert to this and do all of our calculations. So let's practice this. All right? So we want to practice converting. So we have 3 fractions we want to create. 1, 2, 3. We're going to have a top number and our numerators, and we have a denominator that we need to figure out for each one of these. Right? So the denominator never changes. Just quickly fold those out. So it's 3 to begin with, so it's going to be 3 there. Right? 5 to begin with, it's going to be 5 there. So this doesn't change. 3, 5, 7. Right? And let's figure out the numerators. What should the numerator be for the first one?
4.
4. Thank you. 3 times 1
4.
plus 1. Okay. What should the numerator for the middle one be? 47. Yeah. Thank you. 9 times 5 is 45. Add the 2. 47. All right. The last one is probably the one that most students make the mistakes on.
Negative.
It is going to be negative. So our answer is going to be negative. Let's put the negative in. It's going to be a negative number. That can't change. Start off a negative number. It will be a negative number. What should it be?
Negative 1 and 2.
Oh, no, negative 21.
I have 20, 21, 20, 22. I'm hearing lots of different numbers. Okay. So, to do this, ignore the negative sign. All right? We have 7 times 3 is 21. Plus 1 gives us 22. All right? And so it's now, we also have the negative sign out front. Negative 22 over 7. So most people will go 7 times negative 3. You'll give negative 21. And they'll add the 1 and say negative 20. Right? Right? So, does that make sense? Do you guys remember? All right. Okay. So that's usually the easier way. But you do need to go backwards as well. So if you have an improper fraction like this, and so improper means the bigger numbers, top number is bigger than the bottom number. How do you go back to this mixed version? So for example, over here, right? How do you go back and forth? Now we need 3 numbers, right? We have our top number, oops, wrong color, our numerator, we have our denominator, and we need our whole number.
Yes.
You need to come up with the 3 numbers. What's the purple number in this case?
No.
5. It doesn't change.
It stays the same.
That stays the same. So the purple number is 5. All right. What is the orange number?
2. Wait,
So,
What?
how do you know that?
so the purple number is how many full times does it fit in? So how many full times can 5 fit into 13? Right? 2 full times, right? Because 5 times 2 is 10. So it fits in 2 full times.
Oh.
Right? Then the green is
How many you have extra?
how many you have left over. So it fits in 2 full times. Because 5 times 2 is 10. And we are trying to get to 13. So we need another 3 more to get to 13. Right? And that's it. All right? So we're going to practice this. There are 3 more. See if you can do faster. Remember, set up all the fractions. The denominators stay the same. What is the new numerator? What is the whole number outside each of these? Well, I'll talk you guys through this. This is usually the hardest conversion for students, right? So it's going through your head. 5 fits into 12. How many full times? 2. 5 times 2 is 10.
I need help with the last one.
Right? How many are left over? 2. Because we need 10 plus 2 gives us 12. Next one. Right, are you going to help me on this one?
What?
10 fits into 32. How many full times? Huh? 3. Because 10 times 3 is 30. How many are left over?
2.
2, because we're trying to get to 32. All right? Okay, last one. We're weakest usually in our 7 multiplications. 7 fits into 28. How many full times?
4.
4. How many are left over? 0. So if nothing is left over, it fits in 4 perfect times. So we don't need this fraction. It would just be 4.
What?
All right?
Excuse me.
So, it's the way all the assignments go, right? And all the notes go. I teach you the stuff, you're like, yeah, it makes sense. And then Mr. Dhaliwal throws a little twist at you. Right? Because there's always a weird way that some of these numbers and some of these rules get applied. And just don't let it throw you off. The rule is consistent, right? Okay, now, one thing is missing here is I didn't do it with a negative number. Let's make another one of these here. Let's go over here. Let's go negative 16 and a 3 like this.
Really?
All right, so our bottom number stays the same.
5.
How many full times does it fit in? 5. Because 3 times 5 is 15. And we need to make it negative because it's a negative number. And one more left over to get to 16. That's it. Right? It's easy, but it's something that you can remember. You forgot it from last year. You quickly remembered as we went through the examples. When we do our note sheets at the end of this chapter, like we did for the exponents, this is one of the things you should write down. If you forgot it last year, chances are you're going to forget it again by the time June rolls around. Add these little things in, right? If you're just sitting here and watching, this is going to be a little wake up call. Write these things down so later on you can use it. Right? Okay, so these numbers mean exactly the same thing. So this is just going from an improper to a proper mixed format. Right? Sometimes it is a lot easier to work with numbers instead of fractions. It's easier to just work with them as decimals. Right? So we need to learn how to convert fractions into decimals. Remember, this fraction line here, it just means divide. So 3 over 4 like this means 3 divided by 4. So when we're doing our calculations and we want to convert a fraction to a decimal, because sometimes that's quite useful. But you want to go numerator, which is your top number, and you're going to divide it by your denominator, which is your bottom number. Right? So our fraction is just a division operation. Right? So you grab your calculator, and the students often put the numbers in the wrong way into their calculator. It's top divided by bottom, not the other way around. Right? Oh, let's look at this. So you go like this. Hear this. Top divided by bottom is 0.75. And that maybe is something that you should maybe even know. 0.75. Right, so it's just a calculator thing. Now, if you went the other way in your calculator, you'd go 4 divided by 3, which is the wrong thing to do. You notice the number is 1.3333, right? It should trigger that something is wrong because this number is bigger than 1, right? Oh, I got a number bigger than 1. I had a partial fraction. The number should be pure decimal, right? So be careful that you put things in the right way. Fraction, top divided by bottom. That's it. So let's practice this. Okay.
Mr. Dhaliwal.
Yeah. Come. 401. Oh, I'll turn some lights on so it's a little bit brighter. There you go. All right. Let's do the first one. Top divided by bottom. What do you get? 0.6. This is just using your calculator. All right? 0.6. All right.
2.8.
Thank you. Next one. 14 divided by 5. 2.8. All right. Easy peasy. Not a big deal. How about Dhaliwal throws a twist at you? All right? Students usually okay with that. Right? The only thing they do is maybe mix up the order they punch the buttons into the calculator. But sometimes what throws people off is if I say, hey, here is a mixed fraction. What's this decimal version of this number?
Well, we have to convert it first.
Well, there's more than one way to do it.
3.4.
Okay. 3.4, and did you just use your mind to that? Okay, so there's 2 ways to do this. All right? First way is this is 3 full and a partial. So this number is going to be 3 point something. And this is the point. 3 full, that's my 3 full, to the left of the decimal. Then you go 2 divided by 5, right? And 2 divided by 5 is 0.4. So this becomes 3.4.
Oh.
Or, if you don't like that, you could take this number and convert it to an improper fraction and do the calculator for that. You could go with your calculator. The bottom number stays the same. What would the top number be here?
17.
17. 3 times 5 is 17 plus 15 plus the 2 gives us 17.
Wait, how exactly did you get the 3.4?
Calculator.
But wait,
2 divided by 5 is 0.4.
2 divided
No.
All right. Now if I go 17 divided by 5, I get 3.4. I get the same number. So remember, going back to the very first part of this note, we use the word equivalent, equal to. These things all look very different from each other, but they have the same value. This is written as an improper fraction. This is written as a mixed fraction. This is written as a decimal. But they all have the same value, 3.4, or whatever this value is as a fraction format. Same thing, right? So we need to get used to converting a number from one way to the other to serve whatever purpose we're going to do. Right? So today's lesson is just converting. Right. So we talked about converting improper to mixed and back and forth. I gave you a fraction. I asked you to convert it to a decimal. There's one thing left to do. I give you the decimal. I'm going to ask you to convert it to a fraction.
Don't you do like 100?
Ooh, yes. So for all of these, we need to come up with a fraction. And Rylan sort of remembers from last year. We have our top number and we have our bottom number we need for our fraction, right? And our bottom number, Rylan remembers from last year, is a number like 100 or 1,000 or 10. So, something like this. 10, 100, 1,000, and so on. A 1 followed by a bunch of zeros. That's your denominator. How do you know which one it is?
There's like hundredths place.
What? You count the decimal places after the dot.
Yeah. So what will you do is you count the decimal places after the dot. There's one decimal place, so our denominator is going to have 1 0. So it'll be 1 0, like that.
And then the next one would be 100.
Next one is going to be 100. 2 numbers after the decimal. 100. This one's going to be 1,000. 1, 2, 3. Okay? Now, what is our numerator? What is our top number?
The same
Go
thing.
Whatever number is 30.
The same number you see here, but without the decimal. So that is a 3 here. Put my finger over the decimal. That is negative 48. Negative 48. Right? How about the last one? Put my
24.
24. Right? So now if I use my calculator, you can always double check. If you forget it, you can always double check. The first one, I grab my calculator, I go 3 divided by 10. Yes, it gave me 0.3. I go negative 48. Where's my negative button? Negative 48 divided by 100. Yes, it gave you the same decimal. Right? 24 divided by 1,000. No, one too many zeros. Delete. Same answer. Okay?
Yes.
Not too bad. So you know, if you forget it, double check with your calculator. You're allowed to use calculators. Okay? Let's throw a twist in there. Let's do another one. What if I gave you 2.07? I want you to write that as a fraction.
I don't know.
You already given up.
What?
What's the denominator?
I don't know.
How many zeros should the number have?
Oh, 2.
2. See, already saying I don't know. It looks a little different, but the rule is still the same. 2 dots, 2 spots, 100. All right. Same thing as before. It looks different, but the rule doesn't change. What's the top number?
Is it 207?
It is 207. Ignore the decimal. What number do you see? 207. All right. 207. You're not sure? Grab your calculator. Divide the numbers. Did I do it right? 207 divided by 100. 2.07. There we go. That's it. Right? You guys got this, right?